Okay, so I'm sure we've all played games before, whether that's sports, video games, or board games. Personally, I was interested in how we can make machines which play these games much better than us humans can. And specifically, I'm going to be talking about chess engines because they're relatively well known and a lot of research has gone into their development. Okay, it seems to work now. So most mathematicians and computer scientists who build these chess engines are not grandmasters in chess. So how could they possibly build a machine which plays the game much better than they do? Well, the simple answer is that computers are just much, much faster at doing simple computations than us humans, and we can harness that to kind of brute force the game of chess. For any given board state, we can calculate all the possible moves the computer could take. And then for each of these, we could calculate all the possible moves from that position, and then go on and make a kind of tree of all the possible sequences of, say, 3 moves in this case, that the computer could take. So once we have this sequence, all the possible sequences of 3 moves, the computer can evaluate each one and decide on the best course of action. You don't need a computer science degree to build one of these basic brute force chess engines yourself. In fact, I made a basic one last year for my personal project. One drawback of this approach is that it doesn't involve any kind of fancy machine learning algorithm or thinking on the part of the computer. On the other hand, computers are really, really fast at doing simple computations like calculating board states. So if we took this basic brute force chess engine and played it against the best chess player in NIS, maybe Mr. Prosek, the leader of the chess club, who do you think would win?
Mr. Engine.
Well, I'll tell you right now that Mr. Prosek would get blown out of the water every single time he played. I can say this for sure because this is essentially how all chess engines in the world run. It's how Deep Blue beat Garry Kasparov in their famous match in 1997, I think. And Stockfish, the modern golden standard for chess engines, is essentially just really, really fast at calculating possible board positions. It's so fast that on average for every move it takes, it looks 80 moves ahead, which is pretty ridiculous if you think about it. So just how good are these chess engines? Well, in 2014, Stockfish played against Hikaru Nakamura, who was ranked 5th in the world at the time in chess. As a handicap, the engine played without one of its pawns. Nakamura managed to draw the first match, but lost the second against the crippled engine. So why should we even play chess if computers can play chess much better than we can? Well, computers and chess engines are not the end-all solution to the game of chess. Instead, they are a tool which should help us improve and interpret the game of chess better. Oh, I forgot to talk about this, but not all chess engines run like the brute force method I described earlier. So Google DeepMind made a chess engine 4 years ago, which was the first chess engine which really did incorporate some kind of AI component. And it trained over the course of 2 days by playing millions of games against itself. So unlike the traditional chess engines, this one learned its own strategies. For example, Stockfish, humans had to input what was advantageous to the computer, whereas a chess engine like AlphaZero, the one that Google made, would learn all these strategies on its own. So back to my point. Why should we even play chess if these computers can play it better than us? Well, these computers are a tool which help us improve and understand the game of chess better. For example, if you've ever played a game of chess on chess.com, you know that the engines that chess.com uses help us understand which of our moves are good and which of our moves are bad. Furthermore, if you've ever watched professional chess, you know that they have chess engines that are running in parallel to the actual matches being played, so that the audience can understand whether a move made by these grandmasters was good or bad. In the past, before the age of chess engines, the audience would have been lost unless they were also very, very good chess players. So, in conclusion, I'd like to say that game-playing AI make games more fun and richer to play by helping us improve and understand these games better. Thank you.